Hello and welcome to episode 32 of SAAB Fever and episode 2 of this little series here we're doing on the BlueSAABs. My name's Frank, and as you would expect, we're carrying on with the BlueSAAB module here. We're going to solder a few of the remaining components on before we then start to test it in the car. Now, obviously, this is what you'll receive from JLC PCB if you followed my instructions from the first video. And this is our target. This is what we want the board to look like. There's not a lot you can do diagnostics wise. I mean, there are a few things we can do, step-by-step instructions just to check as we go. The first thing I'm going to do is check the power supply. Now, I'll be honest, most of the time I tend not to bother because it actually tests so little. I've got my bench power supply providing 12 volts, so these aren't connected to a voltmeter at the moment. So this should be 12 volts, so I'm going to provide 12 there and the ground. And hopefully you can see that the little red LED has lit up. I can take it off, put it back, take it off, put it back. Now, let's turn the power supply off a sec. Now the reason I tend not to do that, if I get in a bit closer and show you, is it really all we're testing, because this area here is the power supply, really all we're testing is that the power is working. That's nothing else really. The power comes in here. There's a few places it can come in. Should I tell you? Do we want to know? Ah yeah, what the hell. When programming it, you do it through the FTDI port here, and you supply power to this pin here, which goes through the diode to the underside of the board. You can also do it through a USB port. Now, in the bill of materials, the USB port is actually listed. It's one of the things that's listed as optional. You don't actually have to do it. The reason it's optional is the guys have stated that, in short, somebody needs to write a USB driver for it. Now, if someone did do that, then obviously we would be able to program it through a USB port rather than through a sort of a chip programmer that we'd need to buy. But for now, anyway, I don't see much point doing that. You're adding expense and difficulty of soldering with very little to gain, really, because even if in the future someone does that, you would need to use the FTDI port to load the new firmware on that can use the USB port. So, yes, I don't know how likely that is to even happen, so I don't bother personally. But it can be powered through there also. Both of those go through diodes to the other side of the board on this track here, and then comes out just after the diode from the car power into the regulator. Regulator converts the voltage for us. It's worth pointing out this entire side is ground, so all these big traces you see here, not the lines of the traces themselves, not the traces, that's all ground, with this lot being VCC going through to this side of the board, at which point all of this is VCC. There is also power here, but that's direct. Don't use that. Well, I mean, you can, but you would have to put 3.3 volts there. Anything else will probably fry something. I'll be honest, I don't even put pins on those ports just to dissuade people from trying to plug into it in the future. But anyway, let's crack on. Now, I wasn't sure at first how I was going to show you all how to do this. The reason being, some of these parts, especially here, some of these parts are absolutely tiny. Let's get my soldering iron. Make sure it's not on. I mean, you can see the tip of the soldering iron here, and unfortunately, I'll zoom in. Hopefully you can see it there in the light. There are 3 little contacts underneath, and you can see the size of the soldering iron in comparison. So I tend to do them all using hot air, which I appreciate not all of you will have, but personally I wouldn't like to even attempt that with a soldering iron. So Rather than create that difficulty, what I'm going to try and do is show you how I do it. And obviously you're welcome to try a different way yourself if you want to, but I'm going to show you how. Also, my method uses hot air and copious quantities of flux. Now, the point of the flux, the flux, for those of you that don't know, flux will really help the flow of the solder. I mean, ultimately that's what it's for. That's what's in most of the solder. Let's see if I've got an example here that actually states it has a flux core. No, none of my solder reels even actually state that they have flux core. For the most part, the solder that you have, such as this, will actually have flux in it already. Very little though. When you have it on the soldering iron, you see that smoke coming off. That smoke is the flux burning away. This method, what we're going to do, we're going to use the syringe and we're going to put it on ourselves. Should I do the rest of them while I'm here? No, I'll come back to that. I should probably have prepared myself first, shouldn't I? Right, that's turning the soldering iron on. Need to wait a few seconds for that to warm up. Basically what we're going to do, we're going to put the flux on ourselves so that there's loads of it. I'm then going to use the soldering iron with some solder on the tip, rub it over the area, and what will happen, because of the flux, the solder will flow from the hot iron onto the pads, those 3 pads that I need. Then I'm going to leave the flux on, and I'm going to use hot air on the area again to basically get it all up to temperature, make that solder molten again. And I'm going to bring in with the tweezers, like so, but obviously lined up properly, and drop it into place. And what will happen, because the solder is molten already, is this will basically sit in place by itself. You sometimes need to nudge it a little bit, not too much though, because obviously you're blowing hot air. These things have a tendency of flying off if the air's too high as well. But yeah, what will happen is the surface tension of that molten solder will also basically, if we imagine this is the 3 pads on the board here, and this is the thing I'm trying to solder, what will happen is even if I put it on slightly skew-if, it'll kind of go like that by itself and be held in place. So that's the plan anyway. I'm just going to clean the tip. Get myself a little bit of solder onto the tip. You see all that smoke? Like I said, that's the flux that's in the solder burning away. That should be enough. And there we go. Maybe a teeny bit more. Not too much. There. So, obviously, this is the theory of it all. And if you see here, we're looking at those pads here. So yeah, we've got blob. There's a little bit of discoloration. That's actually from the flux itself. But hopefully you can see there are actually little blobs of solder sat on those pads. In fact, I'm just going to check that. Yeah. There we have it. There we have it. And so with that done, now I'm going to position it in a way. Now thankfully the little resonator here has no polarity, so it doesn't matter. Doesn't matter if you put it on this way or flipped around 180 that way, makes no difference. Okay, so here we go with the hot air gun. Put it on at a distance first, just to heat the general area, because obviously these large copper planes here, they can act a bit like a heat sink. There we go. Now, I would recommend, and obviously I'm going to have a hard time showing you that, but what I'm going to do is now have a damn good look at it under a microscope. Yeah, that's pretty good if I do say so myself. Let's see, can I line this up? There it is, but can I get it in focus? No, I can't. Wait, yes I can. There we go. That's pretty good. Now, I don't know if you saw from a distance, but the surface tension did its job and basically sucked it into place. Now, this kind of work really, it's probably not as difficult as I'm making it look, to be honest. And I don't have the steadiest hands anyway, you know. I'm not great at it, and these things are tiny. So it can be done. You know, that tiny little thing with those 3 tiny little blobs of solder on them, it can be done. Even with someone with, you know, unsteady hands such as me. Right, now that we have... Now, it's probably worth pointing out, actually, in my haste to do this, I think I've missed a few points. Yeah, I will. Right. We don't actually... Well, no, I take that back. We do not need the oscillator here to actually function in order to program the chip. We only need it to run the chip. The chip will not run without this, but we can program it without this. But I think what I will do now, I will do the bare minimum required to get this chip programmed. For that, I will need a switch and some pins. Now, I realised after doing the first video, there's actually something I forgot to tell you that you need to buy, and that's a few strips of the pins. How many do we need? 1, 2, 3, 4, 5, 6. We need 6. So, we do 1, 2, 3, 4, 5, 6. Grab it there and snap. There we go. There's our 6 pins. They can go there. Now I find this, certainly this is the easier bit, and also a bit more conventional. I'm going to heat the pin and the pad, and then bring the solder to them. There. And you'll see it's not even remotely straight, but that's okay, because just make it molten again, move it around until it's straight. That's still not quite right, is it? There, that's straight. And now we can do the others with ease. So, bring that. Bring the solder to it. There we go. Heat the pad and the pin, bring the solder to it. Come on. Obviously, again, check your work. Yep, that's fine. Right, next up, we need the boot 0 button. Now, the reason for this is normally when the chip turns on, it starts executing instructions at a set memory address. We don't want it to do that, and what we want is to have the other little program that's on the chip, which basically just listens to the FTDI port here. It just listens on that port and then starts writing. When it receives the data, it starts writing to the area of the chip that it will run from normally. So what we need to do is the exact same again. Let's get in here and yep. Yep. Just check those again. Fine. Okay. Still in frame, yep. Just checking. Button on standby. Hot air again. Just checking it's up to temperature. Ow. Yeah, it is. gently heat the area up and then go in for the kill. I might check. Yep. And remove heat. And check my work. Yep. Right, now I am actually at the stage where we can program the chip. Okay, I've got my little programmer here. I've already marked the pins because it kept confusing me every time. So we can see here we have RX, TX, VCC and ground and an unused pin here. So when the board wants to receive there, so I've drawn these little arrows. So that's the board's receive, that's the board's transmit, that's power. And when I hook up this, it should light up. And it does. Good. Now, at the moment, the chip's absolutely useless because I wasn't holding down the boot 0 pin. So programming can't happen right now. So ordinarily, the guys would tell you, obviously, you hook up reset and you can you hold down boot 0, press reset, and what will happen at that point is the chip will reset, detect that boot 0 is being pressed and go into this sort of bootloader kind of thing. I'm going to cheat and I want to do as minimum work as I can. I'm going to press that and then power up the board. That will have the exact same effect, except I didn't have to solder in another chip. Okay, so to the computer. And here we are on the computer. Now this might be a little different for you guys depending on what chip you've decided to put on the board. If you've put on the real ST Micros chip, then you'll need to use the STM32 Cube programmer. It's basically the same as what I'm about to do on the cheaper Giga Devices chip I'm using. Connect to it here once you've configured the port appropriately. Select Open File, and you'll be able to download it to the chip. However, because I've gone for the cheaper Giga Devices chip, I need to use Giga Devices' own programmer. You can see it's basically the same, all the same stuff's there really, you know, it's just a different programmer to do it. Again, everything's set up already here, the chip's already been specified down here. So if I hit connect now, what should happen is it will connect to the chip, it'll stay connected, and more importantly, it'll show the flash size down here and also the SRAM size. So hopefully this works. And it did, good. So we are now connected to it, we're talking to the chip. I need to browse the path. I think I've got some on my desktop. There we go. Yeah, I'm not going to change this, it's already set. So I'm going to leave that as it is. Necessary erase. That should be fine. I mean, we should get away with a necessary erase and not a full chip erase. And I am going to leave verify after download ticked. This way what it'll do is, well, the first step it'll do is it'll run an erase of the various flash cells on the chip. Then it will write to those cells. Then it will read back from them and compare it to the file I told it to write. That way we can be certain that it's actually on the chip. So let's press download. There we go, we're erasing. And it's quite quick, it doesn't take long. We're downloading it now. Okay, and now we're finished. Now I did fast forward through that just to save us all a bit of time, but as you can see the total time was 43 seconds, so it's quite quick. Right, I think we're done now, back to the bench. And so now with the chip programmed, if we reset it again and plug it in, we should see the green light flash occasionally. There we go. There we go. Can you guys see that? Bringing it up closer. Hopefully you can see that it is green. You can see it flashing in the camera. So good. So now, to me, that's a heartbeat. That means it's alive. Now what the green light actually represents is communication on the CAN bus. So at the moment, the chip is trying to contact the car through the driver onto the CAN bus here. So that's fine. That is perfectly good. Right, we might as well push ahead. We'll do the reset pin button while we're here. Then we'll move on and do the actual Bluetooth module itself. So, put some out there. Clean the tip again. Solder. Get some solder on that. A bit much, but that's okay. There we go. Reset switch. Position the board that way. Hot air. Get a little closer, give it a little poke. I'm basically just checking to see if the solder's molten. Yes, it is. In. Remove heat. Inspect my work. Yep, that's fine. Okay, I will now crack on. Where did I put them? Oh, you'll have to give me a sec. I don't actually know where I put the Bluetooth modules. Okay, I found them. Fine. Panic over. I really need to be more careful given how rare these are. I went and lost a small box of them. Now, these are quite different, the way they mount to the board. Let's have a closer look. See how they've basically got these ridged connectors down the side. What they're going to do is it's going to sit on the board like this. And once we get them lined up, and then we're going to solder all along. I tend to... I don't know if I could. Would it be easier to use hot air on this? I honestly don't know. How I've done it up until now, and I'll show you how I've done it again, is to basically hold it in position like this. Get some flux. There we go. Get a nice bit of flux. Plonk it down on the board. And then get the soldering iron. I won't show it just now, I need to sit down to do it. Soldering iron tip, which won't focus. Preloaded with solder, and then place it on the board here. So that's what I'll do now. Let's get that. Let's get a nice blob of solder. And on we go. Now really at the moment I just want to get 2 or 3 soldered properly, because that will just hold the board in place. Let's clean the tip before I put it away. Let's see if we can have a good look. There you go, see I've got a few soldered on nicely, holding it in place. So it's not going anywhere, and that frees me up to do the rest of the board. So let's push on a bit more flux. There it goes there. Bit more for the back. A wee bit more for that side. That side's looking a little bit dry. There we go. That should be enough to let me do the rest of the board. The Bluetooth module, that is. At the moment, I'm just doing it quickly. I'll come back to it all in a minute. Check which ones have worked, which ones haven't. Do any cleanup that's necessary. So I've got no flux there on that one on the end, so solder isn't flowing. I didn't do very well on that side at all. Also, we need to check that we're not causing any shorts. But again, for the most part, the flux will take care of all of that for us. Okay, that side's looking like it's done. Okay, I need that little bit of flux on the corner there. There, done. Right. Again, just going to check my handiwork. Yeah, all good on that side. All good on that side. Not quite. Right. Oh, didn't realise the camera had gone out of whack. Yeah, right. Probably won't be able to see it, but I'm not happy with that corner there. Go under a little bit of magnification for you. See that corner there? That's not great. Everything else is pretty good. But not that corner. And that's why it's important to check your work as you go along. A bit more solder. There we go, that's that done. And that one there too. Right. Check my work again. Yes, everything looks fine. Right, now, any of you particularly eagle-eyed will have noticed that on the bottom of the module, here's this other one. On the bottom of the module, there are these pins here, or these pads here. Now, I've chosen to ignore them in all of these. The reason being, now, obviously they must kind of be important, otherwise the designers of the Bluetooth module wouldn't have felt that they needed to. But they're all connected to ground, and this pin here and this pin here are also ground, as are this pin and that corner pin that I just showed you I had trouble with. The entire underside of the Bluetooth module is a large ground plane as well. Now, they obviously felt it was important to ground everything as much as they could so that it didn't interfere with the Bluetooth signaling, but it's basically impossible to get that done properly, so I just make do with that entire ground plane being grounded here, 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 and here, and not here as well. So it seems to work absolutely fine that way, so I'll carry on doing it. Right, let's power up the board again. And what we should see this time, I'll only connect the power pins. We don't need data with the board. So as I plug into the ground here, I've got the power live, but obviously it's not being grounded at the moment. What we should see is the green light. We should also see a green light and a blue light flashing on occasion. That means that not only is the chip trying to talk to the car, but it means that the chip is in communication with the Bluetooth module and that things are trying to happen on the Bluetooth as well. So here goes. On. Let's bring it up. Alright, see blue, green, red. Blue, green, red, blue, green, red. Bring that a little closer. Hopefully we can see. There we go. We can see colour now. Good. So far with all of that, what do we know so far? Well, we know the power's working. We know the chip's working. We know that our software is on the chip and it's running. We know that the chip's trying to communicate over the CAN bus. We know that the chip is talking to the Bluetooth module and the Bluetooth module's trying to do things. So the final thing, well, two things I suppose, is put the amplifier on, put the big connector on, and then go test it in a car. So, a bit more flux. A little more. Plonk that down there. Soldering iron, clean tip. Pre-tin those pads. A little more. And those ones too. You don't need to push hard, really just letting it wipe over them. Clean my soldering iron. Right, hot air and chip. Right, now the chip. Here's the chip. Now hopefully you can see. I don't think you can. I can't see it myself. There it is. See that little circle? That indicates the orientation of the pin. And I will bring up a clean board so it's easier for us to see. That little circle. So that tells us what way around the pin, the chip needs to go on. So it's basically this way, right there. There you go. Sit back there and get the hot air. Yep, that's hurting. Good. Just gently heat up the area that we're going to be working. And then go in for the kill. Put that in place. Nope, not quite ready for it yet. There we go. Give her a little nudge. Remove the heat. And I've lost my magnifying lens. There it is. Alright. And check my work. And no. Right. Now I hope you can see this clearly enough. But I do believe there is a little solder bridge there on that pin closest to where the dot should be in the corner. So I'm going to see a little bit more flux, specifically in that corner. Clean my soldering iron tip again, just to make sure. Heat. hopefully, because of the flux letting it solder, that should hopefully have flowed away. Yes, brilliant. There's that. See if we can get that same corner again. I know the focus isn't great, but it does not appear to have a bridge anymore. Good. Right, last thing then. The socket. No, not last thing. Not last thing at all. I need more pins. I need to do this one and this one. Again, I'm not going to do that one. I think that one's kind of dangerous. If people go plugging in like 5 volts to it or something, they're likely to burn the chip. There. Right. Let's get those done. Will that one be easiest to do first? I have no idea. Again, heat up the pin and the pad, bring the solder to it. Come on, there we go. Nowhere near straight. It's fine, make it molten again, straighten it up. Perfect. Here we go with the next one. Come on. There we go. And then the one for the communication with the BlueSAAB. Come on, there we go. Nope, not even slightly straight. Straight. There we go. There we go. I've never actually used this one here. Still in shop? No. This one here, never actually used it. This one will give you some limited diagnostic output if you hook that up to the computer and use either something like PuTTY or Hyperterminal. When the device boots up, when it boots up, it will actually sort of report some data here. Usually it just says something akin to, hello, I'm a BlueSAAB module, this hardware version, this software version, I'm initializing the Bluetooth, it worked, stuff like that. So now we can move on to the actual connector itself. Sit it in. Again, much like the other stuff, just put it in and worry about if it's straight afterwards. Heat up the pad and the pin. Introduce the solder. There. Yeah, that's actually straight as it is, actually. Woo! Ooh, not the nicest soldering, but we'll come back to it. We'll do the rest. That is dreadful. I'm doing well here, am I? Right. Turn the tip again and have a look. Now I can tell, don't really need a magnifying glass to see most of these. I've not done very well at all on those. No, the left and right audio channel's looking okay. Might want to do L plus again, actually. That ground one's not particularly nice either. Right. Clean, clean. Let's redo ground. That was the first pin I did, if you recall. I'll try and get some of that blob of solder off. And what was the other one? L plus. Wasn't too happy with how L plus was looking. Outcast isn't looking great under this light either. It might just be shadow actually. Alright, one last time, inspect my work. Yeah, that's better. Right, so as far as we are aware, we now have a fully functional BlueSAAB 6.1. Let's go to the car and try it. But that's going to have to wait till part 3, I'm afraid. So until then, thanks for watching.